Welcome to the session on cloud computing and its application. This is module 2. The reference book is Mastering Cloud Computing, author's name Rajkumar Bhuya. So in this particular unit, that is cloud computing architecture, we will introduce you to what is cloud, what's a cloud reference model, different types of cloud, economics of cloud, and so on. So, and what is cloud? As we have discussed in the previous session, cloud has different definitions. Each individual have their own viewpoint about cloud computing. So all these technical experts have given a conclusive uh, theoretical definition, that is, cloud computing is a utility oriented and an internet centric way of delivering IT services on demand. These services cover entire computing stack from hardware infrastructure to virtual machines to software services. So all this put together, we call it as cloud, and this definition is as per your textbook. Coming to the next slide, let us try to understand what is the cloud architecture. The diagram over here explains what exactly is cloud architecture. Cloud architecture is how individual technologies are integrated to create clouds IT environment that abstracts, pool and shares scalable resources across network. Cloud architecture is how all components and capabilities necessary to build a clouds are connected in order to deliver online platform on which application can run or a client can use the services. Cloud are considered platform as a services since cloud provider supplies users with both the platform and the underlying IT infrastructure. Architecting a cloud platform requires not that just abstracting the computer capability from its hardware component, which is how provider caters and offers cloud infrastructure to the users. It also requires additional levels of development like routing, like API, security management, automation software, etc. User experience design, or in short UX, is also a vital point. While there are variations of cloud architecture based on what you are trying to do, most cloud requires hardware, middleware, management, and automation software. Like in this diagram, system infrastructure, core middleware, user level middleware, and user application. So let's try to understand each one of them, each one of these layers. System infrastructure. System infrastructure is nothing but the cloud resources or the hardcore hardware which provides the necessary horsepower or the necessary requirements of the client. This layer is implemented using data centers in which hundreds and thousands of nodes are stacked together. Cloud infrastructure can be heterogeneous in nature. Varieties of resources such as clusters and even networked PCs can be used to build cloud architecture. Other services are also storage and other infrastructures also is included in cloud architecture. Now, this cloud architecture or the system infrastructure is managed by the upper layer, that is called as core middleware. What is the role of this core middleware? Core middleware is nothing but an interface or an interlink, to be precise, between the client and the host architecture. It has virtual machine managers which controls the flow or which controls the calls to the system, which helps in resource sharing. There is a quality of service which has to be maintained, service level agreement, and as we know, the cloud is nothing but a metering, works on metering basis. So pricing, accounting, execution management, quality management, monitoring activities all are done in this core middleware. So the physical infrastructure is managed by the core middleware, and the main objective of this is to provide a runtime environment for application and best utilization of the resources. The combination of cloud hosting platform and resource is generally classified as infrastructure as services solution. The same is depicted in the diagram. So infrastructure as a service is a suitable solution which provides system infrastructure, but it has its own limitations and does not provide services to build application. Such services is provided by cloud programming environment and its tools, which forms the third layer from bottom in this architecture. The range of tools includes web-based interfaces, different frameworks, command line tools, and so on. User develops their applications using an API exposed at the user level middleware. Hence, this particular cloud programming environment is also known as platform as services, because the service offered to the user is a development platform rather than an infrastructure. Topmost layer of this reference model, has depicted in the figure, is contains service delivery delivered to the application level. These are mostly referred as software as services. In most cases, web application that relies on cloud to provide services to the end users. In short, the categories of clouds are infrastructure as services, platform as services, and software as services. Infrastructure of services, customers are provided with virtualized hardware, storage, and other hardware and other infrastructure. Whereas in platform as services, the clients are provided with platform to develop the application hosted by the cloud and hosted in the cloud. In software as services, customers are provided with applications that are accessible anytime from anywhere with help of different uh, front ends, like with help of web 2.0 and so on. So the best example for software as services can be Google Apps or Salesforce CRM, whereas for platform as services it can be Microsoft Azure, Google App Engine, and for infrastructure of services we have Amazon EC2, GoGrid, and many more. So in the previous architecture, we had seen three categories of cloud services, that is infrastructure as a service, platform as a service, and software as a service. Now we will start with infrastructure as a service, or also known as hardware as a service. It is one of the layer of cloud computing platform. It allows customer to outsource their IT infrastructures such as server, networking, processing, storage, virtual machines, and other resources. Customer access these resources on internet using pay as per use models. In short, pay as per usage model. In traditional hosting services, IT infrastructure was rented out for a specific period of time with predetermined hardware configuration. The client paid for the configuration and time regardless of the actual use. With the help of infrastructure as service or hardware as service, cloud computing platform layer, client can dynamically scale the configuration to meet the changing requirement and are built only for the services actual used. So, infrastructure as services, cloud computing platform cannot replace the traditional hosting methods, but it provides more than that, and each resource which are used are predictable as per their usage. I mean built as per their usage. Infrastructure as services, cloud computing platform may eliminate the need of in-house IT department. It will need to monitor or control the service setup. Now let us look at this diagram, which is classified into three layers. The bottommost layer is the physical layer, the middle layer it is called as infrastructure management software layer, and the topmost layer, that is web based management interface. So we already know about the physical layer. All the infrastructure like your hardware or your storage, etc., can be put into physical layer, as shown, for example, data centers, clusters, etc. Let us talk more about the infrastructure management software. What is this infrastructure management software and what are its roles? Primarily, as we have discussed earlier, all these facilities provided in clouds are on billing or metering basis. So the first functionality, that is pricing and billing, helps the client and the infrastructure service provider to bill the client as per the usage. Now this billing might be done on usage basis or for a specific period or time or as per the requirement of the client, and all these agreements are done on a white paper, or we can also call it as service level management or service level agreement is done between the client as well as the service provider. What is the role of this monitoring component helps to track the execution of each VM instances created and also maintains the data required for reporting and analyzing the performance of the system. Same way, all this as we discussed earlier will be documented in an SLA. The reservation component stores the information of all the virtual machine instances that have been executed or will be executed in future. Like an library index, VM image repository provides a catalog of virtual machine images that a user can use to create virtual instances. Same way, a virtual machine pool manager is responsible for keeping track of all the live instances. Let us look at the rightmost component, that is provisioning. What is this provisioning? If the service provider is able to handle, or if the service provider supports, then any services which are not within its infrastructure can be procured or can be rented from a third party infrastructure as a service cloud platform, and this is facilitated using provisioning. So this is the middle layer, that is infrastructure management software. Now the topmost layer, that is web based management interface, is the layer through which a client will access these services through either web services or different portals, etc. Few of the advantages of infrastructure as services can be stated as shared infrastructure, web access to the resources, pay as per use model, focus on the core business, that is infrastructure as service provides focus on the organization's core business rather than maintaining its infrastructure on demand scalability. Few of the disadvantages which the clients are worried about is the security, continuous maintenance and upgradation, interportability might be an issue. Now, let us talk about the second type of category, that is platform as a service, or we also call it as PaaS. Platform as a service provides a runtime environment that it allows the programmer to easily create, test, run and deploy web applications. The client can purchase the application from a cloud service provider on pay as per use basis and access them using internet connection. In platform as a service, backend scalability is managed by cloud service provider, so end user do not need to worry about managing the infrastructure. Platform as a service includes infrastructure like servers, storage, networks and platform like middleware, developmental tools, database management system, business intelligence and more to support the web application life cycle. Now in this particular reference model, you see that there are three layers. The first layer would be the physical layer, the second would be the core middleware, and the third is the web interface. The core middleware plays a vital role in connecting the physical resources to the client using web-based interface. So we will not talk much about the physical layers because we have already discussed it, we already know it. Let us talk about the core middleware. Now, the first feature, that is elasticity or scalability. Application deployed can scale from 1 to thousands of users without any change to the application. The application management is a core functionality of the middleware. Platform as a service implementation provides application with a runtime environment and do not expose any services for managing the underlying infrastructure. Automate the process of developing of application to the infrastructure configuration application components. It also manages the system changed based on the policy, that is SLA or QoS set by the user. All these are discussed in SLA management and billing technique. Resource management is how the client receive the resources and the pooled resources are shared among the clients. Now, platform as a service platform as service providers provides the programming language, application frameworks and database and other tools. The basic advantage of platform as services are simplified development, low risk, pre-built business functionalities, instant communities, scalable as we discussed. What would be the disadvantages? Few of the disadvantages are vendor lock-in, that is one has to write the application according to the platform provided by the vendor. So the migration of application to other vendors would be a problem. Data privacy might be an issue. Integration with the rest of the system of the application also might be a challenge. Few of the prominent providers or service providers are Google App Engine, Salesforce, Windows Azure, App Fog, OpenShift, Cloud Foundry for VMware, and the client or the user will be accessing all these services through web-based interfaces using web services or programming API and libraries. The third category is software as a service or also called as SaaS. Software as a service is also known as on-demand software. It is the software distribution model in which services are hosted by the cloud service provider. These services are available to end user over the internet. So the end user do not need to install any software on their devices to access these services. There are following services provided by SaaS providers. Business services. SaaS provider provides various business services to start a business. ERP, that is enterprise resource planning, CRM, that is customer relation management, billings and sales, document management, etc., social networking, mail services, all these are provided by software as a service. A software delivery model providing access to the application is done through internet through a web-based services. So let us try to make a list of characteristics of software as a services. SaaS is easy to buy. SaaS pricing is based on monthly fee or an annual fee subscription. So it allows the organization to access the business functionality at low cost, which is less than the licensed application. Application servers are wide range of users and can adapt to specific needs with little or bare minimum customization. One to many SaaS services are offered as one to many model, means a single instance of application is shared by multiple users. Less hardware required for SaaS, low maintenance is required, no special software or hardware version required, multi-device support. SaaS services can be accessed from any devices such as desktop, laptop, tablets, phone, or even a thin client. Multi-tenancy is possible, API integrations, no client-side installations. The disadvantages of software as services may be security, latency issue. SaaS data and application are stored in cloud at a variable distance from the end user. There might be a possibility that there may be a great latency when interacting with the application compared to local development. Total dependency on internet is one of the key issues. Switching between SaaS vendor might be difficult. Popular SaaS provider are Microsoft Office 365, Google App, your Salesforce, NetSuite, GoToMeeting, Oracle CRM, many more. In this video, we have discussed cloud architecture, cloud computing architecture, which elaborates on the cloud resources, hosting platform, cloud programming and environment and tools, and cloud application. We also discussed three categories, that is infrastructure as a service, its advantage and disadvantages, platform as a service, and software as a services, its advantage and disadvantages. In the coming future slides, we'll discuss type of clouds starting from public cloud to private cloud to hybrid cloud and community cloud. And we will also try to understand the economics of cloud. Thank you.